Alright, let's take a quick look at the same voltage, current, and resistance measurements for the parallel circuit for week 11. So here's a reminder of what the circuit setup is going to look like. You'll configure this in class and then take measurements on it. Let's switch over to the video and take those measurements. Let's start off with the voltage measurements. Switching this over since it's warning us. And let's set it up for just a single circuit. So the easiest way to do that right now is we'll just remove these wires. Okay. So again, checking the voltage on the power supply using the making contact with one of the wires that's sticking into the 3.3 volts and making contact with one of the wires sticking into the negative side. So while it's operating, the voltage is 3.146. All right, so now that same voltage, let's check and see the measurement across the resistor that's in series with it. And again, 3.1314. Okay, now switching over to current. Milliamps is the range we're dealing with. Oops, unplugged the wrong one again. There we go. So again, the couple of ways we can measure the current by removing this wire or this wire. And so we'll do it this way first. Just move it out of there, make contact with that wire, and then restore the circuit that it was completing already. 3.18 milliamps. And just to clarify, I'll restore that and pull this one free and measure the current and make contact here. Again, 3.1718 milliamps. So again, the current's consistent going around the circuit. We'll restore that. All right, so we have voltage and current measurements there. Let's add the second resistor in series, or in parallel, excuse me, and a second wire connecting them. All right, so switch back to the voltage measurements and check the voltage from the supply. Again, making contact here. 3.149150. Little fluctuation. Checking the voltage across each resistor. 3.14. Did I miss something? There we go. Had an incorrect circuit. And let's double check that one more time since I made a change to the circuit here. I had accidentally plugged the brown one into the 3.3 volts. So we'll check this 3.113, the first resistor, 3.09, and the second resistor, 3.096. All right, so that's the voltage for the source and the two resistors. We'll pull out, we want to find out how much current is going through the first resistor. We'll just set it aside here so we can make contact with it. Again, we'll make contact with the original resistor and then close that circuit again. 3.14. Oops, got to switch to current. And make contact by sticking it in the hole with the wire and in the hole with the probe. 3.12 milliamps. It's just coincidence that these numbers are very similar. Okay, we'll restore that one. 3.12 milliamps coming through that resistor. Set this one back as well. Make contact here. And 3.12 milliamps also going through this resistor. So the voltage across them is the same and the current through them is the same. Now let's check one more thing. The current going through each one of these. Let's also check the current coming from the source to feed each of those. So we'll make contact here and restore it. So here the current is twice as much. Instead of the 3.12, we've got 6.18. Okay, so again, that's the current. If we switch screens again here, the current coming from the power supply is feeding two resistors in this case, and the current going through each of them is in around the 3 milliamps, but the current feeding both of them needs to be twice that. And so you'll complete the last measurement. Let's go ahead and set this up. Set up the last parallel circuit and complete the same set of measurements in Studio for the current flowing throughout this circuit now. All right, so that's an end of the week 11 activities. We'll do a little bit of more work in week 12.